Hello guys, this is Tony here. Today we'll be doing inductance. What is inductance? Inductance may be thought of as constant L, which relates magnetic flux linking the, the circuit to the current I flowing through the circuit. And then we must always know that wherever there's a current flow through any conductor, there is going to be a magnetic field within and around the conductor. Then a change in that current will produce a change in magnetic field. A change in magnetic field will induce voltage within the length across the length of the conduct. So let's work on some formulas. Okay, let me make an example here. um, Let me draw an example of a inductor. This is the mean. This here is the mean circumference. This is the mean circumference, and then we have a wire. There's a current here. Current through the inductor. Is the current through the inductor. What happens there is there's going to be a voltage VL, and then what's going to happen now is we're going to define the forcing function of the magnetic field. The forcing function of the magnetic field, which is called MMF, which is magnetomotive force, and is represented by this sign here, and then its formula is equals to number of turns multiplied by current through the inductor. So what is this? This is the number of turns. This is the current flowing through the inductor. So you must also know that the MMF, which is the magnetomotive force, produces magnetic flux. Therefore, the formula of the magnetic flux is equals to permeability of the core material, area, length, magnetomotive force. What is this? This is permeability of the core material, Then this is the cross-sectional area of the core, and then this is the mean circumference. This is the mean circumference, and then this is the MMF, magnetomotive force. Motive force. Okay, so this page is full. Let me go to the next page. Okay. It's fine, right? Yeah, it is fine. Okay, from now, then we must also know that this thing, this permeability can also be represented as, this can be equals to UR UO. UR is dimensionless relative permeability. This is permeability of free space. And then what we have here is, therefore, the formula for magnetic flux is going to be R O area over length. Whichever one you like is fine. Okay, so now we're going to define permeance. Permeance, which is equals to, this is the sign for permeance, which is equals to permeability of the core material area over length. I think you must also notice that this is coming from this formula of magnetic flux, which is permeability area, mean circumference, magnetomotive force. This is permeance. We call it permeance. And then we also have reluctance. What is reluctance? Reluctance is represented by R, which is 1 over permeance. 1 over permeance is reluctance, which is equals to, we have L area. This is in Henry's. This is per Henry's. Therefore, we can say that magnetomotive force equal magnetic flux reluctance. You must also notice, the similarities with Ohm's law. Ohm's law is V equals IR, which means resistance can be related to reluctance, current can be related to magnetic flux, voltage can be related to MMF, which is magnetomotive force. And then what we have here is going to be